Hello, YouTube. This is Umozo3. In the previous two lessons, we brought up the fundamentals of object-oriented programming, and we said it's nice to work with ints and floats and tuples and booleans, but eventually it's going to be helpful, and it's really going to open up a lot of doors for us if we can keep track of different data types, different types of data. What if we wanted to keep track of person objects or car objects or dog objects, right? And then every type of class, every type of object is going to have two intrinsic aspects of it, right? It's going to have variables or values or parameters or properties that are important to it. For example, I'm an instance of the person class, so I have a name and an age, right? But then there's also going to be functions that are specific to a particular class. So a dog might be able to bark, but a cat would not be able to bark. Instead, in a cat class, you might have a function called meow. Okay, so basically we can specify what types of properties slash variables and also what types of functions slash actions we would want to be part of a function. We get to basically declare and decide for ourselves what's important to keep track of, okay? And so we're trying to distinguish between a class and an instance, okay? So remember, a class is a blueprint. It's a general architecture of variables and functions available to members of that class, okay? So we've already seen a definition of a class in the previous two lessons. We talked about a person class, right? And so this is a general architecture, and we said first, a class might have class variables, okay? So all instances of the class are going to have these values of the class variables unless that particular instance changes the value for that instance. So remember in the previous lesson, we said that the income class variable here is 0, but we have a work function, okay? And this is called an instance method, okay? That's why we say self here. It's not an input. It's not an input to the work function. It means Python. This is a function that you need to call in a particular instance on a particular example person. And then for that particular example person, that specific person's income would increase by 10,000, but the value of the class variable would still be 0 in general. So hopefully that's clear to you. Okay, and an instance is like an example object. Okay, so if person is a class, then a 22-year-old Pete would be an instance. Okay, and we talked about a constructor, and we said a constructor is sort of like a function, right? It creates an object by assigning the object's important variables to particular values that the user specifies when he or she is creating the instance. So let me show you what I mean by that. We didn't talk too much about this word, but this is basically how Python signals a constructor. So you need to write def just like you would for a function, and then you're going to write underscore underscore init underscore underscore. So this is basically initializing a person instance, initializing an example object for the person class. Okay, self, that means you're creating an instance. That's not an input, it means you're creating an instance, right? The two inputs are n and a here. Okay, and so what this function does, what this constructor does, there's only 2 lines in it. And so it says for this particular instance, we'll assign the value of their name variable to n, the first argument that was passed in. And for this particular instance, we'll set the value of their age instance variable to a, the second input that was passed into the constructor. So if you said a equals person of Pete and 22, then self.name will be, the name instance variable is Pete for a, and the age instance variable is 22 for a, okay? But the name instance variable would be Tori for W, and the age instance variable would be 39 for W. So hopefully that's clear to you. That's called a constructor, okay? And so a constructor, right? And so the init of self and NA, and you can specify how many arguments you want to feed in. You could have had a constructor that didn't take any arguments, right? You could have a constructor that takes in 10 arguments, right? And assigns 10 instance variables if you think that there are that many important properties, okay? But those are values that are initialized when the object is being created for the very first time, okay? Self must be the first argument for all functions with a class, and it means that it refers to a particular instance of a class, okay? So init would be used to create a specific person object by assigning the name and age variables to whatever parameters n and a were passed in when the constructor was called, okay? So x equals person of na, so we already know what that means. A Python enhancement proposal, just like there are 2 lines before a function definition, Python or PyCharm, the IDE, might get upset with you if you didn't leave 2 lines blank, right? So then it goes ahead and underlines it, and then if you go ahead and space it back out, then there's no problem, okay? And remember self.p, if you say self.p, that refers to variable p as it pertains to a particular instance, okay? So every person object will have a different value for the name variable, okay? But every person has the same value for the can speak variable. So what's the difference? The can speak is a general class variable. And right now we only have two functions in our class. We have a work function, which increases the income instance variable, and we have a get birth year function, which simply returns basically 2021 minus the value of the age instance variable for that particular instance, okay? But there's no function that changes the values of these instance variables. So that means for any particular instance of the person class, for Tony, for Tom, for Cassandra, Cassandra dot can speak is true. Okay, that's an example of basically calling an instance variable, right? So for like instances will take the values of class variables unless the instances change those class variables for themselves, right? So for the work function, we said that a particular instance's income could increase by 10,000, but we saw in the previous video that the income class variable is still going to be 0. So hopefully that's clear to you. Okay, so self.name equals n assigns the current instance's name to n. That's an example of something we saw in the constructor. Okay, all methods in the person class start with self as the first argument. That implies that they're instance methods. In a future video, we're going to learn that not all functions in a class have to start with self. They don't all have to be instance methods, but for this video, that's the approach that we're going to take. Okay, and so can speak and can fly, remember those are class variables rather than instance variables. And right now we don't have any functions that change the values of those variables for a particular instance of the class, right? So we couldn't let Tori fly. We couldn't silence Sam, right? Those are just true for can speak and false for can fly. But the income variable, would be changed for a particular instance if the work function is applied to that instance, right? So the income of that particular instance would increase by 10,000, but only for that instance and not for the class as a whole. Okay, and so get birth year, remember this is the last function we have. So get birth year seems to accept an input called self, but remember if you see self in that function header, it's not an input. It means that refers to an instance method, right? And it returns an integer. So you would have to say print of x dot get birth year. It's an instance method, so you need to call it on an instance, and it's a return method rather than a void method. So that's why you need to print the result of it, okay? But x dot work is a void method, which is why you wouldn't say print of x dot work. You would just say x dot work, and then it's capable of actually printing something within that function, as well as adjusting the value of the income instance variable for that particular instance, okay? We also talked about inheritance, right? So we said a subclass can inherit a superclass, okay? A subclass will take all the functionality of the superclass, and then it has sort of three options, I guess, or any combination of these things, right? So it could either just accept all of it, right? And so we could just go ahead and say that student is going to extend person. That's the example that we saw in the previous video. And then if we didn't write anything else in the class definition, then student would just work the same way as person. So everything that person was able to do, student is also able to do. Okay, so that would just be identical inheritance, I guess you could call it. But then what it can also do, what the subclass can also do is two things. Number one, it can create its own variables and functions, right? It can have its own functionality that pertains to a student in particular, but not to a person in general, right? So what if you wanted to have a student study? What if you wanted to have a student drive to school, right? Those are examples of functions that you would call on student objects, but not on person objects in general. The other thing that the student class can do, that a subclass could do, is redefine variables and functions that have already been referenced in the superclass. So let me show you a couple of examples of that. Remember in the previous video, we saw that the income instance variable for the person class, the income class variable for person is 0, right? But then if you scroll down, we see that student is going to take person as its superclass. Okay, so student will be the subclass. And we already have an income variable in person, but now there's another income variable here. So we say for student objects in particular, the income is not 0. It's 20,000 when you create the student object, okay? But if you hadn't written that, I don't know why it says line 234, right? But if you hadn't written this, then income would have been 0 because it would have inherited that variable from the superclass. Here's another example of what we have going on here. So work of self, right? And so we said in the previous video that basically what some function does is it calls the superclass's version of the function. So what you would have to do is you would have to say, well, how does the person's work function work? No pun intended, right? So you would go ahead and print this thing to the console. So if a student wants to work, what does it do? Well, if you looked in the definition, we were just down there and it said super.work. Okay, so that means we have to go think about what a person would do if it would work. So if the student is going to work, the student is going to say, I need to go to work now. And then the student's income is going to increase by 10,000 because that's by virtue of this line. That's by virtue of 117 that those two things are going to happen. We say, Python, just go use the superclasses implementation of this, right? And then we can also have it do one more thing. We can have it do one more thing. So this expands on it a little bit. I don't want to just print, I need to go to work now and increment income by 10,000. I also want to print, I cannot be late for my work study, right? Because presumably students would be working in like a work study or financial aid, like an after school type thing. Okay. So that would go, that's called an overridden method. Okay. There's no get birth year function. Okay, so do we have to override get birth year? Remember, that was a function that showed up in the super class. Okay, so if we don't do anything with this function, it works the same way in the subclass. And so I think at the very end, we called x dot get, we printed x dot get birth year, right? And we said that even though get birth year, even though this function is not defined in the student class, since it's defined in the super class to student, student will use the super class's version. Okay, so this is totally legitimate. And then we also said that subclasses can have functions that superclasses don't. So fun function, right? And then this is another example of function that doesn't accept any inputs. But what you could do is you could say something like you could say presumably that could be a numerical input, right? So you think of length of a name being an integer, and if we're going to add something onto it, then a has to be an integer, right? And then you could go ahead and run this. So you could say x.fun function of 10. Right? And then we can go, let's just go ahead and run main.py. We just want to get an example. We just want to understand what's happening here, right? So we created a student object, right? And then we asked to print their income. And so that shows up as 20,000, not as 0, right? Because the income class variable was redefined in the subclass. And then we worked, and so we printed both of these two things, right? This is from the superclasses implementation, and this is from what the subclass added onto it, right? And so now her income goes up to 30,000. And then we said x.fun function of 10. So what does that do? So then essentially what we're going to do is we're going to print the length of Tori's name plus 10. So that would be 4 plus 10, and that's why we see 14 there. But that's an example. It looks like the fun function accepts two inputs, but remember, self is not an input. Self means that it's an instance function, an instance variable, an instance property. So hopefully that makes sense to you. But fun function, that only shows up in the subclass, right? So what if you said y equals person, right? We already saw this, y equals person of Pete and 15, right? So now if you say y dot fun function of 20, this is going to be a problem, right? So now if we go ahead and run it, it's going to say, I don't know what you mean by fun function. Okay, so hopefully that's clear to you. What we're going to talk about now, there's actually two other things I want to talk about. So what we're going to do is we're going to say that if a particular function accepts an input, then the subclass definition needs to be understanding of that. So what we're going to do is we're going to go into the superclass and we're going to add an input k to the work function. So now instead of just increasing their income by 10,000, we're going to increase it by 10,000 for however big k is. So what we're going to do, and we're going to say k is positive just by assumption. So we're going to say for t in range of k, okay, and then what we could do is we could say income plus equals 10,000, right? So if k is, and then self.income, right? Because it's an instance variable, but that would increment their value by 10,000 every time, right? So now this function accepts an input. And so now if you go ahead and scroll down to the subclass, there's a problem here, okay? Because it says that the signature of the method does not match the signature of the base method, okay? So basically, if f of x, accepts some input in the superclass, then f of x must accept the same number of inputs in the subclass. Okay, so what you'd have to do, you'd have to go ahead and put an a in here or something, okay? You'd have to go ahead and specify an a here, right? And then you could specify what kind of input you wanted to feed in to the superclass's implementation of the work function. So let me show you what I mean by that. If you just type in a right now, right, and then you had called, a student object and you had said, x.work of 3, it would just increment their income by 30,000, right? Because you just fed it in with the exact same number. But you could make an adjustment. You could make an adjustment to this where you say dot work of a minus 1, right? So then on a student object, if you said x.work of 3, it would only increment their income by 20,000, okay? Because the argument that's going into the superclasses version would be one less than the argument that you like fed in. Okay, so it would subtract one from it. But the point is that you can make any type of adjustment here. You could have a constant. So what if you just wanted to just have a student increase their income by $80,000 regardless of what input you put into here? So that would be another way to do it. This is just putting a constant input and applying the superclasses implementation, right? But we're going to neglect the subclasses input and just use the superclasses implementation with a constant input of 8. But anyway, you can get creative with that and figure out what you want to do for that. What I'm going to do is I'm just going to subtract the input out of there because I want my work function to just not accept any inputs. Okay, so you're just going to say self.income plus equals 10,000. There's one other thing I wanted to talk about in this video, and that's called the string function. So basically what the string function will do is basically this will return a string representation of printing an object. Okay, so here's what we mean by that. We already know how to print the name or the age of a particular instance, right? We can say x.name or x.age. But what if we wanted to print an implementation of a person object? What would it mean to print a person? Okay, so what does that look like? Would it give their name and their age? Would it say name is age years old? Like how would Python know what to return for something like that? So basically, if you have a function with str and then you have 2 underscores before it and 2 underscores after it and then self, right? It's an instance method. So this instance method allows us to specify what appears if we try printing an object, printing an instance of this class, Okay, so let me show you what I mean by that. What we're going to do is we're just going to go ahead and say x equals student of Torian 22, and we're just going to say print of x, okay? And we just want to see a string representation. We just want to print this student object. So let's go ahead and figure out what's going to happen if we go ahead and do something like that. So now we're going to go ahead and run main.py, the executable Python file, and it says Tori is 22 years old. So let's figure out why it did that. In our str method of the person class, remember this is a student object, right? And student doesn't have a str method. It doesn't have a method that would basically indicate how a student object is to be printed. Therefore, it's going to use the superclasses implementation. So if we scroll up to the person's definition of str, you can basically see a str method right here. So we're going to use this implementation. And we said if we try printing a person object, if you say print of x for some person object x, it's going to return that particular instance's name, concatenated with the word is, concatenated with the string representation of that instance's age, concatenated with the words years old. And that's why for this particular student instance, we said Tori is 22 years old. Okay, we could have another example. What if we want to have a set of objects, right? So what if we want to say P1 equals student of Kim and 19, and then we could say P2 equals person of Dave and 33, and then we could say P3 equals person of Kayla and 44, right? And then what we could do is we could have a set of people. So we could say set of people, right? We've studied sets and tuples and lists and dictionaries, and hopefully at this point you have no problem comparing and contrasting between them. But these are 3 distinct elements. There are obviously no duplicates in here. And then so what we could do is we could say something like for W instead of people, we could say print of W. Okay, and so this would basically print the string representation of each person as was defined in underscore str underscore underscore of self. Okay, and this is very specific notation. This is how your function has to look. Okay, if you've ever studied Java, it's the equivalent of the toString method. So now we can go ahead and run it, and we get the 4 string representations of those person objects. And what enabled us to do that was to use the str function, to build an str function which returns a string that makes sense in the context of our program. So hopefully that makes sense to you and that was interesting, and we'll continue on object-oriented programming in the next video. From UMills03, thanks for watching, and please subscribe.